In math today, we're going to learn two different strategies to help us multiply. The first one is repeated addition. Now, I'm going to go quickly in this video, so make sure that you pause at different spots so that the students can keep up. In multiplication, the X, or the multiplication symbol, can stand for different things. In repeated addition, it's going to stand for groups of. So in 5 times 4, I can read that as 5 groups of 4. And the first number in your multiplication equation stands for how many times that you're going to add or how many groups that you're going to draw. And that second number represents the number that is being repeated or added over and over again. So let's solve 5 times 4. And again, this should already be glued down in your notes from yesterday. Only write in that column that says repeated addition. So 5 times 4 means 5 groups of 4. I'm going to represent my groups by drawing lines with some spaces in between. So 1, 2, 3, 4, 5. And I'm leaving spaces because I'm going to go back and write an addition symbol in between each of those groups or lines. So I have my 5 groups and my equal sign and my addition symbols. And the second number in 5 times 4 is the number that's being added over and over again. So I'm going to go back and plug in 4 in each of those groups. So now I have an addition sentence that I can solve. I'm going to look to my doubles facts. 4 plus 4 is 8. 4 plus 4 is 8. 8 plus 8 is equal to 16. And I can't forget that last 4. 16 plus 4 is equal to 20. Now moving on to my second example, 6 times 9, or 6 groups of 9. I'm going to draw 6 groups. Again, leaving spaces between each of them so that I can go back later and show you that and write that addition symbol. That second number in 6 times 9 is the number that is being repeated over and over. So on each of my groups, I'm going to write the number 9. Now you will have more space in your notebooks to show your work. So I'm going to start by adding my doubles facts. 9 plus 9 is 18. 9 plus 9 is 18. And 9 plus 9 is 18. I'm going to add my 2-digit numbers using standard algorithm. So off to the side, I'm going to write 18 plus 18 on top of each other so I can more easily see when I need to carry. Starting over in the 1 spot, 8 plus 8 is equal to 16. Drop my 6, carry my 1. 1 plus 1 plus 1 is 3. But I'm not quite finished yet. I can't leave out that third 18. So from 36, I'm going to add 18 again. 6 plus 8 is 14. Drop my 4 and carry my 1. 3 plus 1 plus 1 is 5. So 6 groups of 9 is equal to 54. And let's move on to 3 times 7, or 3 groups of 7. Again, that first number represents the number of groups, or the number of lines that I'm going to draw. In between each line, I have my addition symbol. And then the second number in 3 times 7 is the number that is being added over and over. So 7 plus 7 is 14. I'm going to add that third 7. 14 plus 7 is equal to 21. I'm going to let you solve the last two on your own. Let's look at the other page that you already glued down in your math notebook, using multiplication on a number line to help you solve these equations. So earlier I mentioned that the X can stand for many things. And in this strategy, 3 times 5, we can also read it as 3 jumps of 5. So the first number in your multiplication equations stands for the number of jumps that you need. And your second number stands for what you were counting up. So in 3 times 5, I'm going to have 3 jumps, and I'm going to be counting up by 5 each time. Every time that you are working with a number line, you start at 0. So I'm going to draw a big dot at 0. And I'm going to count up by 5. You only start counting up after your pencil moves. I'm going to have my pencil starting at 0. After I move, this will be 1, 2, 3, 4, 5. And when I count up by 5, I'm going to draw another big dot, and I'm going to connect those dots. So right now I have 1 jump of 5. I'm going to keep going because I need 3 jumps of 5. So starting at that second big circle, I'm going to count up by 5 again. 1, 2, 3, 4, 5. I'm going to connect my big dots every time because I want to visually see those jumps. And I'm still not at 3 jumps of 5, so I'm going to keep counting. 1, 2, 3, 4, 5. And again, connect my big dots. There's not a number at that last big dot, but that's what my answer is supposed to be. I'm going to use the numbers that are already labeled on this number line to help me figure out what number should go at that last tick mark that I have my dot on. So if this one is 10, and I'm counting up, this would be 11, 12, 13, 14, and 15. So 3 jumps of 5 is equal to 15. Looking at the next example, 4 times 2, I'm going to have 4 jumps of 2. And again, that second number tells me what I'm counting up by. I always start at 0. So the first big dot goes at 0. I'm going to count up 2, 1, 2. Again, make sure that your big dots are in the same spot that mine are. I don't have 4 jumps yet, so I'm going to keep counting up by 2. 1, 2, connect my big dots. 1, 2, connect my big dots. 1, 2, connect my big dots. As I'm connecting, I can see and visualize how many jumps I have. That's why connecting them is so important. So I know when to stop. So right now I have 4 jumps of 2. There's 1, 2, 3, 4. And again, that number is not labeled. So I'm going to look at the numbers that are labeled on this number line. If this tick mark is 10, I'm going to go backwards to find my missing number. This one will be 9, and this one would be 8. So 4 jumps of 2, or 4 hops of 2 is equal to 8. Do the last 2 on your own.